Here's a new demo of Gianni board NavLog with a flight plan import from SkyVector. My starting point is a custom template that I created to fly from Kenmore Air Harbor to Lake Isabel. So I have a NavLog page on the right. I have a NavLog companion tile on the left, along with a couple of checklists. And I have this very simple flight plan from Kenmore Air Harbor to Lake Isabel. The reason why I'm using this as an example is because it has a couple of altitude transitions which require some calculation using POH values. I just want to show you how straightforward it is to make these calculations with the latest version of GNE-board. Again, version 10.19. If that's not showing up for you, you can tell, by the way. If you mouse over the right in the bottom right corner of your screen, you should see 10.19/1019, which is giving you the front end and the back end version. So 10.19 is what you're going for. When you export your file here, you go through the Save Send Plan to, and you download an FPL file. So make sure you have everything you need. This is going to give you the distance and headings. It will not give you the altitude, which we're going to fix after the import. So let's upload a flight plan, pick our FPL file, and we start with a bunch of cryptic checkpoints, except for the airport. So everything you create as GPS points in SkyVector is going to end up being this SV something, which is probably SkyVector with an index. But it does save interesting values, which is the distance, so the precise distance. So 0.84058, which matches this 0.84058. So you're getting a good data along with the heading. So it's not showing yet because we don't have the variation. But if you click on the leg, you can see that all the courses are already embedded in the NavLog. So it's actually interesting. In order for us to get a full vertical navigation, we're going to need to insert a couple of points because this is not going to be just straight from A to B. There's a couple of top of climbs we need to insert, as well as a couple of top of descent, actually one top of descent. So let's do that now. Let's name this thing. So this is my left turn after 1,000 feet. So I'm basically flying west for 1,000 feet, then entering that left turn. Then I'm entering a climb to 2,500. So I'm going to start a climb here. Let me show you what I'm doing. I'm going to show you in SkyVector. Top of climb, 2,500. My altitude is 25. And I'm going to be here. So this point is called send point. And I want to be there at 2,500. What I call send point is actually this here. This flag is send point. They call it something else on the chart on the sectional, but the name for float plane is actually send point. So this is send point, top of climb, send point. Then I make that left turn, and I'm starting. So I'm cruising all the way to this point is actually clear of Bravo of the shell 3000. So I want to be at 2,500 here. So this is straight cruise, no altitude change. And this point is my clear Bravo shelf 5,000. And here I want to be at 4,500. So between these two guys, I need a climb, which means I will get to a top of climb 4.5. So 2,500, clear the Bravo shelf, climb to 4,500, cruise a little bit, then get another climb. So my final climb here is going to be to 5,500 going east. We are going even altitude plus 500. That's the hemispheric rule. And then I want to descend back to 2,800. So my top of descent is here. At this point, I'm still at 5,500. And the leg itself is at 2,851 actually. All right, so this is the profile. So if I go back to SkyVector, what we are 0, 1,000, climbing to 2,500. We're staying there for a little bit, all the way until we clear the Bravo shelf. We climb to 4,500. We probably have a little bit of residual cruise here, which is probably that band here. That white band is the residual cruise. Then we climb to 5,500, cruise a bit, and descend back to 2,800. All right, let's see how efficient we are at doing this. So first things first, let's enter our numbers here. Initial 43 gallons, reserve 13. My cruise fuel flow is 9. My descent rate is 500 feet per minute. And my descent fuel flow is 6 gallons an hour. That's going to make my life easier as I'm entering these numbers, because now my defaults are going to be populated. So let's go for it. My magnetic variation here is minus 15.5, which turns my true course into magnetic heading. My ground speed for the climb is 73. And let's look at the POH to give us the time and fuel to get to 1,000 feet. Time is 1 minute. The fuel is 0.4, but I'm gonna add my taxi and run-up fuel, which is 1.4, and that's a new feature in 1019. You can now have a basic calculation in the leg time and distance. We used to have that in distance only, and now you can do also some simple math in fuel and time. All right, the distance is 0.82. That's because our the distance is 1.2, makes more sense. 73 and ground speed for 1 minute gives us 1.2, and our fuel is 1.8. Don't forget to click on the recommended value. It's not something that we want to do for you. We want you to be mindfully using these values. So click on the value you want to use. We're doing the math, but we're not doing the selection. So click it so that this calculation becomes the actual value, and that gives you 1.8, and that's the first leg. Second leg, we now have the magnetic variation pre-populated for us. I'm doing this without winds. Entering the winds is going to make your life easier, but I don't want to skew the result right now, so I'm just assuming no winds for that demo. Magnetic heading is 147 after the left turn. If we go back to SkyVector, we can see that we have that 146 here, so this is the leg I'm talking about. My ground speed here is still 73. I'm still climbing. And again, let's do a little bit of basic math using the POH. So the difference between 2,500 and 1,000. If we look at time, the difference is 3.5 minus 1, 3.5 minus 1, 2 minutes 30 seconds. Our distance is 3 miles due to the ground speed, and my leg fuel is a difference between 1 and 0.4. 1 minus 0.4. Vanilla calculation, you could do this yourself, I guess, but at some point, these become variable. So we used 3 out of the 4. So we used to have 4 theoretical here. Now the climb is a 3, which means this leg is actually going to be 1. So that's the 1 nautical mile that remains from that climb. Magnetic heading doesn't change. Ground speed is 105. Our time is 34 seconds. Distance is 1. Leg fuel is 0.1. The way the fields are organized now make it much more natural to click through left to right. So if you're on a cruise leg, you basically, if you trust the calculation and you confirm they're correct, you can just click them left to right, and that gives you all the values. All right, next leg. I'm making a turn towards the west now. for 5.8 nautical miles to clear that Bravo shelf. This is going to be straightforward. 51 on the magnetic heading. My ground speed is 105. The time is 320. Distance doesn't change. Fuel burn 0.5. So that almost makes the cruise leg seamless in terms of calculation, which is pretty cool. All right, this leg we did a split. So we know, looking in the background here, we know we have 5.2 nautical miles to distribute between the climb and cruise. I'm talking about this here between the two Bravo shelves. So we know we have 5.2 to deal with. Our ground speed on the climb is going to be 73. Let's look at the POH between 2,500 and 4,500. Time-wise, we're saying 7 minutes minus 3.5. Let's do it. 7 minus 3.5. Again, not crazy math. Our distance is 4.3. So I already know what the math I'm going to do for that next cruise is going to be 5.18 minus 4.3. Actually, let's save that. So let's use 4.3 here. My leg fuel is 1.7 minus 1, 0.7. Let's be lazy. Let's do it. 1.7 minus 1, 0.7. And when I go to my next leg, my distance is whatever I had in SkyVector minus 4.3, which gives me 0.9. So that little residual distance we have here is 0.9. We're just putting that here for accuracy. I'll let you guys decide what's best for you, but that this is what the math tells us. All right, we're going to cruise at 105. Our heading doesn't change. Our ground speed is 105. 30 seconds at this fuel burn is 0.1. Cool. All right, last climb. So we're now entering that last climb here. It's unlimited. We have no Bravo shelf whatsoever. We're using the hemispheric rule to figure out we need to fly at 5,500. So let's go for it. We're climbing another 1,000 foot here. Magnetic heading doesn't change. We're climbing at 73. POH tells us between 5,500 and 4,500, the time difference is 2 minutes. The distance, let's save that. I'm going to use that distance. This is the whole distance. 1773 is the whole distance for climb, cruise, and descent. So POH tells me, not POH actually, I know that this distance is 2.4 because I have the ground speed and the time, but the leg fuel is going to be 2.1 minus 1.7, 2.1 minus 1.7, which is 0.4. All right, that's my climb leg. I'm not going to enter this right now. I just want to save 17.3 minus my climb that we did previously, which is 2.4. I'm just going to save this 15.3 for now, and I'm going to come back to it because I need to use some of that for the descent. So speaking of descent, magnetic heading doesn't change. I'm going to descend at 105. My leg time is the difference in altitude divided by the descent rate. So the 5.18 that we have here, you can do the math yourself to check. You basically deduct 2,851 from 5,500. That gives you the difference in feet divided by 500 should give you 5 minutes 18 seconds. My distance is 9.3. I'm going to memorize that because I'm going to deduct that from my 15 here, and my leg fuel is 0.5. All right, I need to remove 9.3 from this, minus the 9.3, which is 6 even. All right, I have my magnetic heading, my speed, my time, and my fuel, which gives me a full NavLog, including all these altitudes. So the key difference here, if I apply, actually, you're going to see that the companion kicks in. The key difference is that all these altitudes require a little bit more calculation, which this recent version makes easier. The companion tile gives you a quick recap of everything that's on the page. Obviously, you can fly with the page. If you don't want to flip the kneeboard, and just for real estate sake, if you want to save space on your knee, having the tile itself is a little quicker. The tile is really dumb. It doesn't have any setting. It just takes whatever is in the page and shows a recap on the front page. That's it. Try it for yourself. Tell us what you think. Use the feedback feature. This is really helpful. All that stuff comes from fellow pilots, so don't hesitate to send us feedback. And yeah, give it a shot.